Hello everyone, my name is Anafisa Nasir and I am a student of BSc in Prosthetics and Orthotics at the Bangladesh Health Professions Institute. In this video, I'll be discussing the concept of movements, what they are, their basic factors, and how they are closely related to biomechanics. We will also explore the significant influence of movements on the design and functionality of prosthetic and orthotic devices. So let's get started. So, first we'll know what is movement. A moment is basically the rotational effect of a force around a point or axis. It happens when a force is applied at a distance from a pivot. For example, spinning a top involves applying a force at its edge, creating rotation. This is a moment. Now we will know how movement occurs. To understand how a moment works, let's take a simple example using a wrench. In this image, the force represented by the downward arrow F is applied to the end of the wrench. The distance between the point of force application and the pivot point, known as the lever arm, is labeled as L. When a force is applied at a distance from the fixed point or screw here, it causes a rotational effect, which is the moment. Moments are calculated using the formula moment equal force into distance. Here, the force applied at a greater distance creates a larger moment, making it easier to turn the bolt or nut. Now we will talk about the types of moments. There are two types of movement, clockwise movement and counterclockwise movement or anti-clockwise movement. Clockwise movement rotates in a clockwise direction in the direction of the clock, and the counterclockwise movement rotates in the opposite direction. In the human body, movements are vital for movement and balance. During walking, movements play a critical role in different phases of the gait cycle, ensuring stability, propulsion, and balance. The gait cycle consists of several phases, each with distinct joint movements. Now we will talk about those joint movements. During the initial contact or heel strike, the ankle experiences a plantar flexion movement due to the ground reaction force being behind the joint. Dorsiflexor muscles, like the tibialis anterior, engage to control the foot placement. Simultaneously, the knee has a slight extension moment, providing stability, while the hip undergoes a flexion moment countered by the hip extensor muscles to stabilize the joint. As weight transfers onto the stance limb, the ankle's plantar flexion moment increases, requiring the dorsiflexor muscle to maintain the control. And the GRF starts behind the ankle joint. And the knee experiences a flexion moment with quadriceps muscles activating to support weight, and the GRF is posterior to the knee joint. The hip continues to face a flexion moment stabilized by the hip extensor muscles, and this time the GRF is anterior to the hip joint. During the mid stance, the GRF shifts in front of the ankle, creating a dorsiflexion moment in the ankle joint. The plantar flexors, such as the gastrocnemius and soleus muscles, act to control the forward motion. The knee has reduced movements requiring minimal muscle activity, while the hip transitions to an extension movement with the hip flexors preparing for the upcoming swing phase. As the heel lifts, the ankle continues to experience a dorsiflexion moment, with the plantar flexors generating significant force for propulsion. The knee maintains an extension moment, which provides stability, while the hip also remains in extension, with flexors beginning to engage for limb advancement.